Hello everyone. This is the third video of the AutoLab series. And in the first video, we have introduced the end-to-end procedure of how to participate uh, in running an experiment in the AutoLab. And the second video, we go into the detailed function of the AutoLab website. When you are running the experiment, you can watch the uh, real-time display over the internet. And so if you have not seen those two videos yet, please watch those two videos first, because this is the third video. A lot of the material presented today will depend on what I have described in the previous two videos. Okay, so today I'm not gonna go into the introduction of AutoLab. Today's goal is to describe a tool that helps researchers on the internet to produce a script, a repeatable script that describes how an experiment should be conducted. Okay. So this is the zip file. This is the zip file of the template script, and the link I will include it. It is not available on the net right now, as of the time of the recording. Yeah, but I will make it available on the internet, and then the link will be below this video. Okay, once you download this zip file, and then you just unzip it to any place, and then you will get a folder called sitemap. Okay, and then inside it, there will be common checker, which are the codes used for any test site. And then for site-specific data, they will be in the folder with the name of the specific test site. For example, demo room, we only have one. In the future, they may have several. Okay, and then this is the outermost structure. So we'll provide those explanation and restriction map. This is basically an array. And then after you get in one layer into it, you'll see this file. This is the file that we are gonna go into detail. Okay, and then eventually the output will be two CSV file, and that will be also generated at this folder. So this script template is serving the purpose of providing a friendly service for human beings, and then translate into the JSON machine friendly language. After you double click that AutoLab demo room template, you will get to this Excel file, and then
Hi,
this is exactly.
hi, JT.
Yes.
Before we go into the details, why do we need a script, and why not simply control the robots and APIs interactively from the website?
If we don't have a script, the experiment cannot be repeated. And then we want to repeat the experiment, and then create a network downgrade, a network performance downgrading scenario. At a specific time, the network is just gonna crash, and then under that kind of situation, we try to find a solution to fix the problem. Yeah. So if we run it without a script, then every time we run it differently, and then we will never know if the scenario are identical or can be compared. Okay, so let's continue. Let's come to the concept of time offset. So at the very beginning, the time is 0. And then what is this 0 time? Can be 2 o'clock today, can be 3 o'clock tomorrow. And then we just add this time offset. So the experiment can be repeated. adding absolute time plus the time offset. That will be the time that a specific action is executed. In this spreadsheet, every 2 rows represent a command. Okay, so I'll name them with number. Yeah, this is the first command, the second command, the third command. Okay, so at the very beginning, you can just click this button, and then if it will jump to another spreadsheet. This spreadsheet is used to describe the initial position of each robot and each AP. And so you can edit the location. This is the initial location. And robot location is supposed to be editable. You can put the location of each robot at the place that you want it to be. Yeah, but the AP, we assume AP is fixed, and then before the beginning of the of an experiment, we'll make sure the each robot is exactly at the location that you want them initially to be. And then we come back to the original spreadsheet. This will provide you the template. Okay. So this is the command numbering, and then you can disable them. You can just create some of them. Create some comments, but some of them can be turned on and off. If it's false, if it's false, then that comment will be skipped. And then this is the time offset. So for example, if you start to run this experiment at 2 o'clock, and then this will be run exactly at 2. This is a minute and this is a second, right? And so this comment will be run at 3 minutes after 2 o'clock. And this experiment will be run at 6 minutes after 2 o'clock. And then what is the target device is described by the scanner. Okay, scanner include the AP and the robot. Yeah, but we'll get into detail later. And then this is the comment column, which comment you want it to run. And then these are the parameters of the comment. So if you pick an AP comment, then you need to click the second button from the left hand side, and then everything you need will be reformatted, and so that this is an AP command. So you can only pick AP, which AP you want it to receive this command. Okay, and then and this command happens to have no parameter. So if you pick one with parameter, like for example this one, and still click GUI, and you'll see all the parameter will be updated. And then, for example, you want to send the traffic to a specific robot, and then what is the parameter that you want to include in the command, and so that will make it very convenient. Okay, and then we'll focus on the mobility command next. Okay, there's a specific rule that for mobility command you always have to start with report location. Okay, because if you don't report location, we are not sure if the robot is really at the location we want it to be. And then any command follow that will be like very risky. And then there's another rule. Yeah, it's pretty conservative now that I require the mobility command to be separated by at least 3 minutes. So let's focus on the mobility command. So the most basic mobility command will be move, and then click on GUI, and then let's see where we want it to be. Let's see the initial position initial position is 10. Initial position is here 1.5, 4.4. Okay, so let's look at the map. 1.5, 4.4. So if you want it to go to this place, this is like, this is how much? 1.8, 1.8, 3.6, 1.8, 3.6. Okay, 1.8 and 3.6. And then you click on this view map. And this map will show you the path. This is the starting point, this is the end point. And then you'll see it will go through this path. And then this is basically the map of the demo room. And then this function is for you to check if the move command or other mobility command is safe or not. Okay, so this is safe because it does not run into any furniture or other robot. Okay, so this grid point, each cell is 10 centimeter by 10 centimeter. Okay, and this ABC is basically the location of robot, and this 1, 2, 3 is basically the location of AP. So this is 6 here, 5 here. These are AP. And then the blue circle, they are the dynamic restriction zone of each robot. Okay, so let's change the number. For example, like 4, 3. Let's say if this is 4, this is 4, and this is 3. See how? Okay. Okay. Yeah. You will see this special symbol here. Yeah, which means collision. It's getting too close to Bravo. Alpha on this path and it's too close to Bravo. So you know you cannot on this path. You have to choose other path. Instead is scan command. Scan start or scan up and scan once. Scan once means you only scan all the SSID just once. Okay. And then scan start means you start to scan the channel once a minute until you receive the command of scan stop. Okay, so this scan start. Where is start? Oh yeah, here scan start, and then there's no parameter, so you can X alpha to start to scan channel, and then you will start to report a channel back once a minute. And then there are a lot of AP commands. Just like you want an AP to get association table, which robot it is associated with. Okay, so there's no parameter, so you can just send it directly. But you need to pick which AP. Okay, and then the other AP command including transmit power. You can control what is the power level that you want an AP to transmit power. And then yeah, the allowed power range is from 0 dBm to 30 dBm. Okay, and AP traffic enable and AP traffic disable. Yeah, this is a pair of commands. And it will as an AP start to send back the statistics of the traffic. Yeah, this is not the traffic of IPOP3. IPOP3 is the source that we arrange a robot to receive or to transmit. So that is a flat traffic. Okay. Yeah, but this AP traffic enable means you will collect the specific statistics that an APC from the wireless network. And let me continue. So then the last step is about the traffic. Yeah, you can the recipient of the traffic is robot. Okay, so if you click on the GUI button, you have to pick which robot you are gonna send the traffic or receive the traffic. Yeah, so this IPOP3 traffic session is initiated by the NMS. Yeah, and then we'll send the traffic to or from a robot, and then it will definitely go through an AP. The AP will be the AP this robot associated with. Okay, and if the direction is reversed, which means it is from robot to the AP, and if it's not reversed, then it's from AP to robot, and then we can specify like voice, video, background, best effort, or the duration. So this is flat traffic pattern. Okay, and then same for UDP. Okay, UDP will have more parameters to fill in. Okay, and yeah, I have detailed explanation in the package, and then so I'm not gonna go into detail. It'll be too much. And then for traffic session, there are 3 commands: start TCP or start UDP, and then the next one is stop. So this one will be rarely used, yeah, because each session has its duration. And if you do nothing after this duration time is up, then this section will automatically stop. So you don't need to send this command to stop it. So if you send a command to stop it, it will be just cut off halfway before it's finished. So there are 5 buttons. Yeah, the first, the leftmost button is to initialize the script, and the second one is for each command to show its parameter, so then you can fill in the parameter. And then the third one is not really important. This is just to create the JSON format. Yeah, and the fourth button, yeah, this is to view the map. We have seen it several times. And then here's the last one. The last one is to check out. Yeah, basically command check. This is the safety check. It will do not only the safety check, it will also do the grammar check. Okay, you can key in whatever you want. Basically, I'll try to implement as few restrictions as possible. But eventually, all the grammar check and the rule check will be done when you hit this button. You will see the failure. You will see the error, and then the error reason will be given below. Yeah, you cannot use AAA. You cannot use AAA. Yeah, here you say you cannot use AAA, and then I just use the AAA. Okay, so try again. So it passed. So it's okay. When I hit this button, the entire script will be compiled and then check against the safety rule. And if it passes, everything is okay, then it's fine. You have an output file, and then you have 2 output files. And then if any of them is not okay, it will show you which command is not good. Yeah, this is the original folder, right? This is the Excel file that we just run. And then if you get into here, these are the two output files. And then we also have this validation report to see if everything is valid. And then if it's not valid, you'll see the detailed information. And so these two will be the files that used to register an experiment.
Hi, JT.
Yes, yes.
Is there any a function in the map? In the map, we can choose the position instead of typing the XY, because we type the position XY is not too friendly.
Oh, okay. Yeah. Originally I was thinking about to provide the way of dx dy, or like distance and angle, how much distance from on which angle you want to move. Yeah, but yeah, that is future possibility. Yeah, if we want a robot to move forward or move in like 30-degree angle to 30-degree angle to the right for like 1 meter. Yeah, that's also possible. Yeah, and that is possible on a lower level command. Yeah, so you can tell the robot to move like 3 meter, 1 meter to the right, and then 0.5 meter forward. Yeah, and then instead of x and y, it's more like dx and dy. The difference that you want the robot to move. That's possible on the lower level command. Yeah, but I do not expose them in this script template. Yeah, so there are like 3 or 4 ways to allow the robot to move. And the lowest level will be like move and rotate. Yeah, that's the lowest level. So I have several levels of describing how a robot should move. And yeah, and the top level is just like the XY, where you want it to be. Because looking at the map, the easiest way is to find its X and Y. And the other, yeah, because for now, if alpha is at this point, and then you want it to move to a specific point, you just read the destination's coordinate vector. You don't have to compare the difference between the starting point and the end point. Yeah, so if you want to move a robot forward by a specific distance, then you need to know the starting point, and then to calculate the difference in the direction and in distance. So that will be more troublesome in my view. Yeah, but if people want that to be included in the script template, yeah, that's easily doable. I can include that. But for now, there's no. Right now, there's no. Yeah. So it's
Exactly, yes.
yes.
Just to check if I understand correctly. So if the safety radius is 0.6 meters, and
Right.
I run 2 robots in the same experiments, does the common checkers check their paths never come within 0.0 meters of each other?
Oh yes. Yeah. There's this like blue circle, right? It doesn't look like circle. Yeah, but it's a circle. Yeah, because it's quantized by the grid. Yeah, but it's a circle. And then for the target robot, it will not hit himself, right? So the moving one doesn't have a circle. And so alpha is the moving one. And then all the blue circle are the dynamic restriction zone. Why is dynamic? Because when each robot move around, and this circle will be dynamic, will move around together with the robot. So it is exactly the 0.6 meter. And then why 0.6? Yeah, because the robot is pretty thin. A diameter is 30 centimeter. And so I double it to make it 60. So that two robots will not collide with each other. Yeah, so exactly when you see a blue circle around a robot, yeah, that's the dynamic restriction zone. So after we get those two files, right? Those two CSV files, then how do we register an experiment? So this will be the last point, last step. And the last step will have nothing to do with the scriptwriter, the internet researcher. Have nothing to do with them. The internet researcher just need to send in the two CSV files. And the two CSV file, how does it look like? This will be the command CSV file. And then the other one, initialization, will look like this one. Yeah, this is not very friendly to human beings. Yeah, but you only need to submit this to CS file to the lab operator, the interface to register the experiment. And each one is an API. Each one is an API. And so if you come to this one, another explanation. Okay. And then this will be the starting point of the experiment. And then you need to pick the file. And you'll pick those two files that we just created. For example, yeah, experiment script. Right, experiment script. The command file, and then the initial position file. Okay, take these two. And then you can specify the section ID. And then, yeah, if this company want to replace the existing one or not. Yeah, but you can ignore it. And the most important item is this one. So, for example, I want it to run right away. So I okay. Wait. Okay, so like this. And then if you hit execute, then the experiment will be registered and it will start to run at this time. 3 minutes after 3 o'clock. And then that's one important point I would like to mention. There's a safety check written in Python, and the safety check code is the same on the web operator side and the scriptwriter side. They use the same code. So if the scriptwriter run the safety check and it passed, then submitting to the web operator, you run the same code, it must pass. So there's no need to worry about arguing if this code is safe or not. As long as it passed the safety check, it should be safe. And then since the code are identical, so if it passed on one side, it must pass on the other side. They share the same code. So what if the scriptwriter changes the safety rule and then make it pass? It doesn't help, yeah, because if it pass on the scriptwriter side by changing the safety rule, it won't pass the original safety rule checker. So just use the same safety check rule provided by us from the internet. Then if you go through the safety check and then append the 2 CSV file, and then you just send in a 2 CSV file, then that must be legal, must be safe. Yeah, because we will run exactly the same safety check rule. And then if it's fine, then we'll schedule a time to run it.
Yeah, I have a question about the error handling. Have you encountered any unexpected situations during the real experiment? For example, the robot not reaching its destination, or a scan returning no result, or some component damage. I'm just wondering if any safety improvements were added to the AutoLab.
Okay, yeah, sure. Yeah, the script template is used to describe the ideal scenario, what you want it to be, how much do you want it to move. Yeah, but in realistic situation, yeah, there will be like location error. The April tag may not give you the exact location, and then you want to turn 90 degree, it may turn 80 degree. You want to walk 1 meter, it may walk 1.2 meters. So we have all this problem, and so there is a specifically designed same machine to deal with this. Yeah, so we have a system of recording the true location, and then another system recording the script printed location, and then these two location will always work its best to follow the script location. So with this way, the error won't accumulate. Yeah, so this is a very sophisticated system to deal with this kind of error. Yeah, and then there's a error limit. Eventually, if we cannot avoid a large amount of error, yeah, so there will be, for example, distance error of like 30 centimeters. That is considered very huge. And if you think you are at this point, but if the true location tell you are 30 centimeters away from the location you expect it to be, then there'll be failure. And what will we do when we run into this kind of failure? We'll stop the experiment. So when an experiment starts, there's no guarantee it will succeed. Yeah, especially when we just start running this system, it's not quite stable yet. So it may possibly just stop halfway. And if it fails to go through the entire script, then we'll have to schedule another time to run exactly the same experiment. Because once it stops, it won't start. Once it stops running, it will not start automatically. It will just stop running at that moment, and then until someone see it, and then reschedule the experiment. Yeah. Okay. So I'll conclude the AutoLab series. Okay. So this is the internet tool for online internet researcher to send their experiments through a script. And so that by using the script template, they can draft a script with a interface that's friendly to human beings, and then after they got a script ready, they can send in to the lab operator. The AutoLab operator will register the experiment to a specific time, announce exactly on the public website, and then you can see it on the public website. You will know when your script will be run, and then at that specific point, you can go to the public website to view your experiment playing out in real time. And then if you want to see the history, you can check the history of the past 24 hours. And we do not allow an experiment to run more than 12 hours. So 24 hours is definitely enough for you to cover the experiment you are running. Okay, so online view and the history view is a tool to help you to make sure the lab is running as exactly what you expect. And then on that website, you can also see the lab, see the real view of AutoLab from the camera of the robot. Okay, and then if the experiment fail, then and there will be a failure reason, and then we'll collect the reason why it failed. Most likely it's the operation error, yeah, because this robot are very low cost, yeah, they are very cheap, yeah, and the cheap robot require very high end software to control, yeah, so the software is very complicated. But anyway, no matter how good the software is, it's still possible to run into error. And so if that's error, the experiment cannot continue, then the experiment will fail. And then if the experiment succeeds, then we will collect data, and then we'll pass the data to the internet researcher. And that will complete the entire procedure. Yeah. So starting with script writing, submitting, and then live demo, and then history view, and then collecting data. So that will end the entire circle. So thank you.